welcome to the first ever MathCast podcast. Just to start off, I'll tell you a little bit about what this really is and what we aim to do. So on this podcast, we aim to bring up interesting and beautiful math topics or problems, and we will be joined by different guest speakers each week to discuss this. For today, our guest is someone that many of you will know. She's an academic scholar from Year 8 Parks, and she is a Math Leap student. She will be joining us to discuss the beauty of Fibonacci numbers. Without further ado, let's get started. Alright, just to start off, let's just tell you a little bit about, firstly, who Fibonacci really is, and more importantly, today is the 23rd of November, which is otherwise known as Fibonacci Day.
So Fibonacci was so important, he gets a day. So some of the most important things he did is he traveled to the east, so the Arabic and Indian regions, and he learnt the number system they use there, which is the one we use today.
Which is base 10.
3, 4, base 10, yeah. And he came back over to the west, in Italy, where he's from, to populate this number system amongst the Westerns.
Without him, we probably wouldn't be using the base 10 number system, or it would have taken us a lot longer.
Yeah, so his real name is Leonardo of Pisa, also known as Leonardo Pisano in Italian.
Yeah.
He's from Italy. And he translated his book Liberace into English. It was translated as the Book of Calculation, and that told the English people to use base 10 instead of using
Roman numerals.
Which would suck, because when you times 2 Roman numerals together, you get a really long Roman numeral.
Alright, so the main topic that we will be discussing today is the Fibonacci numbers. So
Fibonacci actually discovered a sequence called the Fibonacci Sequence.
So it goes 1, 1, 2, 3, 5, 8, 13, and 21, and so on. If you have noticed the pattern, you add the two previous numbers to get the next one. So 1 plus 1 is 2, 2 plus 1 is 3, and so on.
But what makes this sequence different? I mean, it's just any old sequence. There are an infinite number of sequences. Well, this sequence actually has quite special...
an irrational feature.
Yeah.
So let's just try to make this a bit more clear. So let's try dividing the 8th term by the 7th term. So the 8th term is 13 and the 7th term is 8. When we divide them, we get 1.625.
You might think this dividing is a bit weird, but it'll get clear later on. The 30th term in the sequence is 832,040, and if we divide that by the 29th term in the sequence, which is 514,229, we get 1.6180333989. What's so special about this number?
So firstly, the numbers do get pretty big and pretty vast. So this number is actually known as the golden ratio. And the further you go down the sequence, the more accurate it gets to the golden ratio.
But what is the golden ratio? Well, it's also known as phi, and it's supposed to be a number which predicts beauty. It's often used in photography.
It's also used in nature, and the number of spirals in a sunflower is normally a Fibonacci number. The petals in a flower is a Fibonacci number. The way the tree branches separate is normally a Fibonacci number. Population of bees and much more.
So basically, Fibonacci numbers and the golden ratio appear in nature a lot. And isn't it really interesting that all these numbers that constantly appear in nature have a pattern that links them into a really massive sequence?
And the golden ratio is actually irrational, which is the cool thing about it, is that it doesn't stay the same.
You know, when in the Fibonacci sequence, it's quite unique because when you're dividing it, we just get closer and closer to this golden ratio, which predicts beauty and is found all over the world in nature.
Another thing about the golden ratio is something called the golden spiral, which is a spiral that has the growth factor of the golden ratio, meaning that as the spiral gets wider, it gets wider by a factor of the golden ratio each time.
The golden spiral is used in photography for image compositions, and it was even used in the pyramids of Giza over 4,000 years ago. Also, there's something you can do with Fibonacci numbers to make another type of spiral. If you draw a square that is 1 by 1, and then another square which is 1 by 1, then you draw a square that's 2 by 2, then 3 by 3, then 5 by 5, and
going
so
up
on.
by the Fibonacci numbers each time.
And you draw a spiral connecting all of the vertices of these squares. You get something called a logarithmic spiral, which is also used in photography.
So just a quick fun fact before we end, the reason that today is the Fibonacci day is that the day is the 11th month and the 23rd day, which has 4 of the first Fibonacci numbers.
1, 1, 2, 3.
If you have enjoyed this video and you would like some more research on Fibonacci numbers, here are a few other links and videos. There is the Numberphile video, about the Fibonacci numbers. And yeah, thank you so much for watching, and hope you see you next time. Bye!